When we're considering basic integrals for trig functions, we need to make sure that what we're thinking about is what are the derivatives of our trig functions and how do we undo them? So what we're looking for in our integrands are derivatives of the trig functions. So let's first look at the evaluation of sine of x dx. When we integrate sine of x dx, we're trying to find the antiderivative, or what function has as its derivative sine of x. Now, if I recall that the derivative of cosine of x is actually equal to minus sine of x, I am almost to my solution. I need to somehow incorporate a negative sign into this indefinite integral so that I can get something related to cosine of x back. So I'm going to rewrite the integral of sine of x dx as minus the integral of minus sine x dx, since a minus give me a plus, so these are equivalent. Now what that does for me is that now inside my integral I have exactly the derivative of a function I know. I have exactly the derivative of cosine x. So I will replace the integral symbol and this integrand with its antiderivative. So my solution is minus cosine of x plus c. Now we will normally write this simply as minus cosine x plus c without the extra parentheses. Now at this point, once you find your solution, you can always check to see if your answer matches the integrand by taking the derivative of what you found as your integral and seeing if it matches the function inside. So the derivative of minus cosine x plus a constant is minus sine of x from our recall statement plus the constant, and that gives us sine of x. So remember, what we're looking for are integrals that inside are derivatives of trig functions. So now we're going to evaluate the integral of secant of x, tangent of x dx. So we're trying to figure out which trig function has as its derivative secant x times tangent x. And if we recall correctly, we will know that the derivative of secant gives us exactly secant x tangent x. So the integral of secant x tangent x is secant of x plus any constant we want to add to it. Remember, it's important to always add the plus c for indefinite integrals. We can do the same thing with definite integrals, and then we just incorporate evaluation. So here let's look at the integral from pi over 4 to pi over 3 of secant squared t dt. My first job is to figure out what trig function has as its derivative secant squared. And I think tangent. Derivative of tangent is equal to secant squared. So my antiderivative, or my integral, is tangent of t, and now I want to evaluate from pi over 4 to pi over 3. Using fundamental theorem of calculus, I know that we need to evaluate at the top value and subtract evaluation at the bottom. So that looks like tangent of pi over 3 minus tangent of pi over 4. Now we still need to replace these trig functions with their actual values. So let's draw our triangles. Our pi over 3 triangle has an adjacent side of 1, an opposite side of root 3, and a hypotenuse of 2. While our pi over 4 triangle has adjacent and opposite sides with length 1 and hypotenuse of root 2. Recalling that tangent is opposite over adjacent, we can now replace our trig functions with the appropriate ratios. So we have that tangent of pi over 3 is equal to root 3 minus tangent of pi over 4 is equal to 1. So we have root 3 minus 1. And this is our solution, which cannot be simplified further.